Hello everyone, welcome to my channel. This is Bai, and today we are going to look at the TwoSum. This is the number one question in the Leetcode, and I would say this is the most simple question in the Leetcode. The description is as follows. Given an array of integer numbers and an integer of target, we need to return the integers of two numbers so that they add to the target. So in this case, let's see. We were given an array of numbers. From that, we need to find the two element of. We need to find the integers of two elements so that they will sum up to the 9. So in this case, it will be 2 and 7 will sum up to the 9. Their integers are 0 and 1. In the second case, it will be 2 and 4, so their integers will be 1 and 2. And and also you may assume that each input will have exactly one solution. So we don't need to consider for the case where there is no answer in the solution. And also there will be at least two elements in the given array. So I will show you with an animation how we will solve this problem. So I will propose two algorithms. First is the greedy search, or TwoSum is a typical two-pointer array problem in which we need to assign two pointers to iterate to the array. And the greedy search algorithm will output every possible pair from the array. Let me show you about this. So first pointer will iterate from 2, 7, 11, and 15, and that's the normal iteration. Second pointer will start from the next element from the first pointer and iterate to the remaining elements. So it will be 2, 7, 2, 11, 2, 15, and 7, 11, 7, 15, and the 11 and 15. So that is the every possible move in that array. So this is called a greedy search, in which we will search through every possible pair in this array, and we will find the sum of each pair and compare with the target value. If it is equal, then we will just return the index. In this case, the runtime will be n squared because we need to iterate. While we are iterating to the element, we are iterating to the nested element. So we will use the nested for loop for the algorithm. The better solution to this will be using the hash table. In the hash table algorithm, we only need to iterate for one time, and we will store each element in the hash table for the later reference. Let me show you about this. So for example, in the first element, we will store the element to the hash table, and they are indexed in the later column as the value of the dictionary. While iterating to the element, we will find the difference between the element and the. If the difference is in the hash table, then we know that the complement of the element is in the previous element. So we will know their index by looking at the hash table. So this is the animation for this hash table. Let me show you the code. This is the Leetcode. I will first demonstrate the greedy search algorithm. First, I will define a variable of the number of length of the given array, and I will iterate for I in range of n-1. In this case, we will need to define the n-1 because the first iteration number will only iterate to the before last element of the array. So that will be to the last element for j in range of I plus 1. The second pointer will iterate from whatever the first element is plus 1 and to the last element of the array. If the number of I plus number of j are equal to target, then we will return I, j. And this will be the greedy search algorithm in which we will find out every possible pair in the array and compare with the target. Let's see about this, if it works. Yes, it does, and submit. Let's see the result. This algorithm might take a little bit of time because we are doing a nested for loop, and that basically take a lot of time. So let's just remember this. It will take at 4092 milliseconds. And let's use the better algorithm of the hash table. Okay, let's first define the array variable for the number of length of the array, and we'll iterate for I in range of the numbers. Or let's just first define a dictionary. Or in Python, dictionary behind the scene use the hash algorithm to store the data, so we could use the dictionary for that purpose. Let's first define a variable of the different. That would be the difference between the target and the current numbers value. And if the difference is in the result, that means we store it in the hash table. Then we should return the result of the difference and then the I. That is the intent of the two elements. And if it's not, then we will store the number of I with the value of I. That is the intent. And let's see if this works. Oh yeah, it does. And submit, and let's see the difference. So this only take at the 52 milliseconds, while the previous algorithm take at almost the 4092 seconds. So it is a lot faster, especially when the input array gets larger and larger. The difference will be much larger. So yep, this is it, and this is for today, and I will see you next time.